Hello, this is our chance to review through some notes for combining expressions. So variables, a letter or symbol that represents an unknown quantity. We have the following algebra blocks. And algebra blocks are very helpful to put together like terms and develop an understanding of variable. Our first block, as you can see, is y squared. That is why the dimensions are y and y, which is what gives us y squared. Finding the area, y times y, gives us y squared. The second block is y. The dimensions of that are y and 1. Y times 1 gives me y, so the area is y. That's why the block is named y. For our second block, we have x times x. That gives me x squared. We found the area and we know the dimensions. Okay, so 1 times x gives me 1x, or just x. So this would be an area of x. Now this one here, it's labeled xy, which is telling me that there's two dimensions that are different. One dimension x, one y, and we're finding the area. So the area is x times y, and we can express that area as xy. We don't have to put a symbol in between it to represent multiplication. So we have 5, and we have a 1. The little blocks will represent singles. Okay. So to get an understanding, we have math that has its own language of its own. A term is a group of numbers and or variables. And so you can see there's following examples. We have 3x or x, 5 or 5xy, or even x squared. There can be things with exponents that still represent terms. Another word we're going to see is coefficient. A coefficient is the number being multiplied by a variable. So our examples, in 5xy, 5 is the coefficient of the term. There is 5 xy shapes, and so you can see that there's 5 little xy shapes that have been drawn, each one representing a shape. Okay. In y squared, the 1 is the coefficient of the term. So it's representing that there's just one y squared block. An expression is a collection of terms, variables, numbers, and or operations. Expressions can look like many different things. So they could be as simple as 2x and as complicated as 3, 4, or more terms. So here's our first example, 2x plus 3y plus 4. In our next example, 2x plus 10. Some terminology that you'll hear used, especially these first ones, a monomial is an expression of one term. So that would be simply 1x, and you'll see no operations. There'll be no adding or subtraction. Binomial is an expression of two terms. So you'll see two different terms. You're going to have one operation in there. That might look like plus sign, or it might look like a minus sign, but there'll be one operation. A trinomial is an expression of three terms. So you can assume there'll be three separate terms, all separated by operations. And so in this case, you can see that there's either going to be a plus or minus sign or a plus or minus sign. When you have a polynomial, that's a general term used for many. And you could, this right here is a polynomial with 4 terms. You could have polynomials with a number of terms. But it could include everything that's even below it, 3 terms, 2 terms, etc. Okay. As we're trying to put together like terms are terms that have the same variable with the same exponent. Sometimes they just use the word power. Like terms can be combined to form simpler expressions. And so you can see some examples, 3x and x are like terms because they're both the same variable with the same power. 5y and negative 2y, same variable with the same power. So the coefficient doesn't matter on whether you can add those terms together. 3x and 3y, nope, they're not like terms. Okay. They're not the same variable with the same exponent. The coefficient's the same, but the variables aren't the same, so they're not alike. 2x and 4x. The variables are the same. They have the same power. They can be combined. 5x squared and 2y squared. The variables are different. When the variables are different, even though they have the same power, they still can't be combined. 3xy squared and xy squared. Okay, they are the same because they have the same variable with the same power. Now what we want to do is try to take those shapes and then create and collect an expression. So it's the first example that's here. We went through and we labeled each one of our parts. Okay, and then we began to collect all of those. So sometimes the shapes are orientated differently. So XY was like this, but then it became vertical here. We count how many we have. So we have an XY, 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 XY. That gives me the 3XY. We have the X's. That's where I get the 5x. And the x squareds, we have 2 x squareds. We combine those, and that number is the coefficient for that term. Okay. And then we collect the small ones, 1, 2, 3, and then there's a 5 and a 5, plus 13. Okay. These terms can be in any order. Okay. Mathematics allows us to do that, and the rules can say we can add in any order we choose. We can also go in the other direction to help us put together like terms. So we've taken each one of these pieces and we drew out what that would look like in all their shapes. And after we've drew and labeled them, we could collect them. So we know how many x's we have by just at the beginning. So we have 2 x terms, we have a y term and another y term. So that's 3 y's. Look at the coefficient in front, 3y. We have a y squared and a y squared, so that gives me 2 y squareds. And then 7. When we add up all of our little individual blocks, we get 7 is that whole value. Okay. Going through these examples, you should notice that we can draw them out, or we can simply ask if they're like terms, and then we can combine by adding the coefficients together. So 3x and 4x, they're alike. So we can add 3 plus 4. 7x. I could draw 3x shapes and 4x shapes, and when I put them together, it will give me 7 of the x shapes all in one pile. I have a y and a 4y. So that's saying 1y plus 4y shapes, that would collect to make 5y shapes. 2x plus y plus 5x. Well, they're not all like terms. The 2x and the 5x are alike. So those two can be combined to make one group. So we can take the coefficients, 2x and 5x. 2 plus 5 makes 7, 7x. And then we have a y. Again, we can always draw the shapes out to recollect what we see. Okay. And so some of these other examples, this is the one where if I drew them all out, a 2x and a y and a 3x squared, we would not see anything in common. None of these terms are alike, so our answer is just the same. Here we have an xy shape, and a 2x shape. Drawing them out, we would see that these two shapes are the same, so I have 2 xy shapes plus a 2x. Looking at our values, xy, 2y squared, 3x, 2y squared, the 2y squareds could go together, but nothing else can combine. So the xy, just one xy shape. The 2y squareds become 4y squareds, and then the 3x carries on. Can't combine with anything else. Last but not least is example 3y squared plus a y squared. Now if we were collecting the shapes together, we would have 4 of those y squared shapes. I have a 4x squared, that means 4 of those shapes, plus 1 more of those shapes. That creates a 5x squared. This concludes the notes portion of combining like terms.